All right, you ready? We're gonna do this. Can you wave to the nice people? Awesome. Anyone out there you really, really like? Oh, all right. I guess Jeff is gonna be the person he likes the most. This is Hexy. Hexy's gonna be here and help me through this presentation. Enough fun with Hexy. Democratizing hardware is the name of this talk. I am your guide through this, and to be ultra hipster in this domain, I'm using PowerPoint. That may prove to be a bad decision as a life choice. But hey, let's go with it. Because if I'm going to do something, I should do it all out. So who am I? Why am I standing up here? Why do I add any value to your day? Hopefully, I do add value. That's sort of the target. I'm Chris Williams. You probably know me as Voodoo Tiki God if you know me. Not too many people actually even know my name's Chris Williams. They mostly know me as Voodoo Tiki God. I run JSConf, RobotsConf, Capital JS, help set up NodeConf, as well as a plethora of other things. I'm the instigator of the NodeBots, NodeCopter, NodeBots, and NodeRockets. Yes, I said boats. We take geeks, we put them with electronics, and put them in the water. What could go wrong? And I do all that because I am the author of node-serialport, which for most of you, if you've never heard of the serial port, you're like, well, that's cool. That died like 3 decades ago. Why is this even a thing? But the S in USB, to many people's knowledge, is for serial. It's for serial port access, the universal serial bus. So it's still very much alive today, and that's actually the gateway between the magical world of computers and the magical world of robots. And that gateway is a very powerful thing. Also, less important to this discussion, I'm the creator of Beer.js. I also did the JS logo that's been on Colbert Report. That is, in fact, the top point of my life. Everything since then has been not even close. I'm also the founder and CTO of a company called Emerging Technology Advisors, where we take a lot of the stuff that I'm about to show you, and we help large companies, large organizations embrace them and figure out how to bring them into their life. So as part of that, it's good to describe what my quest is. I am on a quest to change this world. My general goal is to take the hard out of hardware, to make the complex things in life simple. It's a pretty simple task, right? No hard things there. I want to make hardware available and accessible to anyone. Right now, there is a bit of a barrier. If I were to ask you what would happen if you licked a 9-volt battery, how many of you, and you don't have to actually raise your hands, but would raise your hand and think that it might erupt you in flames? I mean, it's a thing, it happens. A surprising amount of software developers have been abstracted away from this wonderful world of hardware, and because of that, they are fearful, truly fearful of accessing it, that they may blow up something, that they may burn an LED out that costs less than a penny, that they may erupt themselves into flames. And the likelihood of that, I mean, there is a likelihood of that, but it's not a huge likelihood. And my goal with this is that if I can bring, like Prometheus, if I can bring fire to the world and let the world have it, then they will set themselves on fire. No, that's not the goal. That they will be able to make fire for themselves, cook meals, and go forward. So that is my hope, is the awaiting of the coming of the robot overlords. And ideally, by democratizing access to the hardware and democratizing the knowledge of hardware, I will be able to allow many, many more people to join in on the hardware discussion. So in short, I'm basically trying to make robotics as simple as programming a web page. That's the long and short of this presentation. That's it. Thank you. Bye. The thing with this is that if I make it as easy as programming a web page, I have to make it in something that would be similar to programming a web page. And for better or for worse, and I know there's a general agreement or disagreement, depending upon which side of the aisle you sit, that JavaScript is either the best or worst programming language ever to be created, and should either be used everywhere or die in a fire, respectively, I think. Yes, I said that correctly. So for all intents and purposes, Node.js was sort of the starting point. And there's a lot of natural overlaps that we'll go into. But I didn't want anyone here to think that I'm saying Node.js is the way, the path, the light for this, because it's not. It's just a piece of it. And so that's why I left the 2 blank there for you to fill in whatever you want, however you want. It's, you know, that. JavaScript, for better for worse, has natural overlaps between the hardware world. It's an invented model, is a core part of it, both in Node and also in browser-based programming. And that very much maps to the hardware interrupt style of straight hardware componentry. Not to say that other models don't work, but this just has a natural overlap. You also have the benefit that objects in a OOP world are supposed to render actual objects. But hey, in the hardware world, they can actually render real objects. So I can have a servo object, and I can have it talk to another servo object, and I can have it talk to a board and ports and GPIO dropouts. GPIO, for those of you who don't know, I may use that a couple times. General purpose input output. It allows you to convert that to different signal strengths. Let's not go too far into it. Hardware by nature, up until the last couple of years, is mainly speaking single-threaded. Most of the chipsets you'll buy in an Arduino or other boards are single-threaded. There is only one processor. There isn't hyper-threading. There isn't anything glorious to that effect like you have in a normal computer. It's single-threaded. And so there's a natural overlap with JavaScript, which still works in like the 1980s world and is not process concurrent and doesn't have threads. So there's actually, while that's bad normally, this is actually a perfect world where they work well together. And in both worlds, blocking is a bad thing. So that's why there's also that natural overlap. Most important to this discussion about democratizing hardware is that JavaScript can allow anyone to write code almost anywhere. Now, I'm not putting any qualification on that code. It probably will be bad, but it doesn't matter. It creates change in the real world. It causes something to move, to shift, to change. And this gave rise to a thing lovingly termed NodeBots, which was sort of the rise of this JS robotics ideology. And that has been about 3 years in the making. And it's gone to the point where we have an International NodeBots Day where there are small groups all around the world that get together, bring out different pieces of hardware, completely different projects. People who have never touched computers are able to sit down, work, build a robot, control it, and do amazing things. And part of that genesis and part of that start point was a thing called NodeCopter, which you've probably seen. If you've ever seen like the demonstrations of quadcopters, which unfortunately, I was going to show you a demonstration of it today, but thank you, TSA, we're not going to be able to do that. You're able to control a quadcopter using just very simple JavaScript programming. Take off, land, sort of attributes and functional capabilities. That gave rise to a thing called Johnny 5, which is done by Rick Waldron as the curator and organizer of it. Johnny 5 is a library that abstracts and implements the ideas that I sort of put forward in the NodeBots idea. Let's make rendering a robot like Hexy here very similar to the comprehensions of a document object model, or the DOM. So just as we can render the DOM in a tree form of dependencies, we can similarly render that here. This is connected to that shin is connected to that leg is connected to that foot. And those then create an object model that then we can now work with. And it's a very powerful thing to say, hey, look, here's this thing, go program it. And as just anecdotal evidence, we've been able to work with 5-year-olds to 75-year-olds and allow them to access programming and access robotics through this method. So it's an extremely powerful thing. One of the other things that it provides is, since it's Node, you do have access to a REPLed robotics. And bringing the power of a REPL, the ability to change things in real time as a derivative of the ability of changing code, allows people to make change, understand that if I press this key, if I do these keystrokes, these commands, it's going to cause these change, and actually execute that in real time. And so what I'm going to do here is, if this all works out, where did that go? I'm going to enter this into the REPL. I already have the stream open with Hexy. That's what you saw earlier. But this code set is a great example. And yes, it is callback hell, but that's just part of Node. You source in the library. You tell Hexy to 0, which says, hey, I want you to get all your servos at the 0 point. And then you tell Hexy to get up. And then you tell Hexy to dance. So I'm going to enter those in, since we already have the serial port open here. So I'm going to tell Hexy to go to 0. All right, so this is the 0 position. Hexy is now has all of Hexy's servos at its 0 point. And then we will go in and let me copy this. All right, Hexy, get up. And all it's doing is it's just sending the command, and all the magic happens between the host system and Hexy. It's just sending commands across the serial port to execute this. And as you can see, this is very powerful. It reads similar to English. And so now I can do the last one, which everyone's waiting for, right? Everyone wants to see Hexy dance. All right, we're going to make Hexy dance. And there, Hexy's now dancing. So this shows you a huge amount of power. 0 is actually telling all of the servos here at the same time to go to their 0 point. And get up is telling all of the servos to control themselves such that you put the legs out, drop them, and push them up. And then dance is obviously telling Hexy to dance. It's a very powerful thing that wraps up and allows people to very quickly see, change, do. And bringing that REPL power to developers for communicating to hardware is a hugely powerful and liberating sort of workflow. Coincident to this, and mainly from the other side of it, you have the open source hardware movement. I would hope that everyone in this room has heard of the Maker movement. If not, you owe it to yourself to get involved as part of it. The Maker movement does for hardware what sort of SourceForge early on and GitHub has done for software in terms of let's share ideas in digital form back and forth. And the Maker movement does that similarly of let's share digital designs back and forth between each other, and we can use different manufacturers, different chip layouts, different small batch assembly to create them locally. And by sharing that knowledge, we help the whole world. And this, one of the penultimate beautiful pieces out of the Maker movement is the Arduino. This is an Arduino Uno. This is actually the original heart and soul of the NodeBots. Everything was built on the architecture of the Arduino. And what it does is it allows that to basically become a, if you want to think about it like a RPC handler. Do this, do that, activate this pin, do this, change this, mutate this state, and drives it from the host machine running JavaScript. And so that way, the hardware does what the hardware does best, and the computer does what the computer does best. And that's great, but you have the thing that we have here where Hexy has a tail and can only go so far due to physics. And that doesn't work out well, but the future is bigger, it's brighter, it's already changing right in front of us. You have wonderful things like the Spark board, which is a Arduino-compatible Wi-Fi-based chipset. And what we've done is we've used an adapter model to allow the replacement of any of those boards, the Arduino board with the Spark board, with the BeagleBone, with the Pinocchio, with the Tessel, with the IMP, swap them out at the underlayer and keep that top layer of code that the developer, the person coming on, the child, is able to just learn one code instruction and have it work on multiple platforms. Said differently, we've been able to democratize access to all of these devices through one common interface, that being JavaScript, which is accessible to all, which is a pretty cool thing. And that brings wireless and all. I didn't know that had sound. And coincident with this, you have the ability to gain access to 3D printers, CNC, laser cutters. Basically, this is a derivative out of the Maker movement, where there are maker shops, there are maker spaces that are set up all around the United States, all around the world, where any of you can walk in, get access to a 3D printer, print out whatever you want, and walk out. That's all you have to do. You don't even have to pay for most of them. If you end up signing up, you can. It sort of becomes like a gym membership. But you have access to all these great technologies that are available pretty much free to access. And now that sounds great for you all, but it sounds even more amazing in my mind for pre-K up through post-secondary children who are wanting to change the world. They want to get out there. They want to do these things. And this affords them the ability to do local manufacture, to actually build things they can touch, they can do. And this comes into a combination that provides accessible robots. Hexy here is actually not just the Johnny 5-driven robot. Its pieces are all done through a CNC laser cut on plexiglass. Everything in here, except for like the wires and the servos, is plexiglass that was cut based off of open hardware designs. So I didn't make the hardware designs, I just downloaded them and hit a button to get a laser cutter to laser cut it for me. That's a hugely powerful world. Now, not only do we have access to software readily available, but hardware. And that is transformative. And we're just now starting to crack into what that world looks like. And for me, I want to make sure that access is available to everybody. So a couple projects that we've been working on. One is PavelBot, named after a gentleman named Pavel. I'm not even going to attempt his last name, but I'm something close to Sigmatovich. I think I got it right. I go with Pavel. That's why we didn't go with the Sigmatovich bot. We went with PavelBot. It's a $35 total cost investment to do the wood cutting, the board, and on there is a Spark Wi-Fi chipset. $35 for that whole thing delivered to you, good to go. You have a robot at that point that you can control via a REPL. Even more exciting is something similar to this, which is a drone, a quadcopter. This one doesn't work right now because the battery the battery broke on the way over. The quadcopters have 4, hence the quad, rotors that are propellers that rotate and create downward draft and can be manipulated to be very agile and moving. This is a thing called the FlexBot, which started out as a Kickstarter for an open source design for a quadcopter. The FlexBot is actually designed to be 3D printed so that you could actually print your own quadcopter. If you want to go buy it, it's only $50, which is not too bad. The one over here is a Parrot, it's $100. Both in very much the accessible range to many people. And if you don't have $50 but want to get this, you can go to a makerspace and say, hey, can I print this design? And you get it for $0. A little bit of time investment versus money investment. Now, on the opposite end of the spectrum, this robotics and open robotics idea has blossomed a whole new realm of next generation robotics or larger order robotics. This is an open ROV. It actually runs a BeagleBone Black inside of it, as well as running node.js, as well as running node-serialport in order to control the entire ROV system, robotic oceanographic vehicle. This goes into the ocean or into caverns and takes video streams and sends the HD video back up through Wi-Fi or through a direct channel, depending upon how it's programmed. It can control itself in water completely autonomously or with guided controls. It lasts for about an hour in water. It's fantastic, but the cool thing is that you don't have to know crazy deep sea in, all right, that was a weird word choice, crazy deep programming language C to travel this in the ocean or sea. You can just program it entirely with JavaScript. And you can do it in a REPL so you can make immediate changes versus slapping a firmware down into it and it's locked and stuck. But why? Why, Chris? Why are you taking me on this journey? And why are you doing this mission? What is the reasoning for this quest? That's a great question, and I wanted to show you all the exciting things first. If you don't mind, I'm going to let Hexy go to sleep, just so that way the servos don't burn out. There we go. We can play with Hexy later. Why? Why are we doing this? So let's peer into the future. Let's try to figure out where the next, let's go with 5 years. What does the next 5 years for the world look like? And that may help you understand. So I'm not telling anyone anything crazy when I say the population is growing at a rate that is almost and arguably already out of control, and that will continue to go. This is a chart based off of the US Census Bureau of where the world's going to be, such that by 2020 we're already at about 7 billion people on this earth. When we get to that level, having all 7 billion people working to feed, care, and take comfort of all other 7 billion of them is almost impossible. We will have to have automation. We will have to have robotics. And you're seeing this already as agriculture moves over to robotics, as shipping and logistics moves over to robotics and drone operations and autonomy. We will need something. We will need our tools, our technology in order to support it. If we continue down the path where we are right now, where it's held by a tight group of very, very smart people, then we are stuck. Because if those people pass on, or more importantly, move forward into the retirement or older stages of life, their knowledge disappears with them. and that is a fundamental problem. This is the aging population base. US will hit the baby boomers leaving the market, leaving the knowledge work area in 2020. So in 5 years, 6 to 5 years, we look at most of the existing domain tacit knowledge leaving the domain entirely without any great replacement due to what we've done with our generations. And if you look at it, the generational shift here, you notice that your Gen Xers stay constant all the way through. The bottom is right now, the top is the future. You have your millennials taking over. In 5 years, we will see a massive shift in the workforce where domain knowledge disappears completely. And that's a problem. And unless we make access to this, this is a quote from Intel Labs, that the trends are already indicating the growing numbers of jobs will require significantly more complex interdisciplinary skills such as problem solving, judgment, listening, data analysis, relationship building, collaborating, and communicating with multinational coworkers. In short, we need a lot more people who do everything. That's the long and the short of this. Right now, we're not arming and equipping our fellow humans with that capability. And so unfortunately, we're creating a narrower and narrower pipeline that does not support the infrastructure that we need as a society. And it's my belief that we need to democratize, and you may have different opinion, and that's fantastic, we should discuss it. We need to democratize access to that knowledge. We need to democratize access to the parts, and that's where the open source hardware movement comes in, that anyone can gain access and build their own robot. And I encourage you, go build your own robot, but don't just do it in isolation. Find a 3-year-old and build it with them. Find a 10-year-old and build it with them. That you will change not just your life and their life by building this, you will change society along the way. The more people we give this to, and we make it easy for them to jump onto, we make it easy for them to gain access to control, to build their own emergent ideas, the more people we do that with, the greater societal change we have. And it's because of that that I'm working towards a modern education platform through the use of drones. And at this point, I would show you that, but like I said, the battery's dead. So imagine this drone flying around as I'm talking. In the modern, most of us had some sort of access to the first entrance of programming. Some subset of us had access to that by way of Logo, which was that turtle thing that you made, move one space, and you would see the thing on the green screen, which was horrible, move one space, and turn left, and it would move that. For most people, that's sort of an entry point, because I can see, I can change, I can execute, I can understand the causation of my change. This is that modern platform. I can lift off. Hey, it lifted off. It would if it was working. Hey, turn left, and it would turn left. Hey, go up, and it would go up. Kids get this without any problem. There is no complexity to this. I did that, it moved, yay! And then they start building further and further up to the point where in about a day, you can have somebody, even us developers, can in 8 hours go from no knowledge about programming a drone to creating OpenCV-based facial recognition and tracking drones that can fly and charge at people. And that's only 8 hours for developers. I mean, it took government organizations millions of dollars to make that happen. We do it in 8 hours. Kids can do it in about 3. And they are much better at this than we are because they don't come to it with their preconceived notions. Their minds are clear. They create wonderful things. And it's for this that I believe we have an opportunity to combine the arts, sort of the logic and the creativity, to combine the art and the science of programming. And through those, we can create a much more perfect human and a much more perfect human society. Not focusing on one to the declination of the other, but to work on both as a happy medium. Now, you might say, Chris, how do you do that with this? This is all technology. It is, but it also is not. Much the same way that we use Hexi here to demonstrate that we can do modern fabrication, the artistic quality of, I want to make this round, or I want to make this square, I want to make it have horns on the back, I want to do this. The ability to take a person, set them in front of a CAD program that are very accessible nowadays, and say, create your own thing, create your own monster. allow them to do that, hit a button, print it out in plastic in a 3D form, and generate a robot is incredibly powerful. Allows them the freedom of creativity to create whatever they want, cast it into the real world, and control it. And that's tremendously powerful. If we want to look even further than just 5 years out, there's also another reason why we're doing this. Programmable matter. If you don't know what programmable matter is or have not yet heard of it, you should. As you look at the atomic structures of elements, there's ability to create and isolate electrons that can present like their own atom, brand new atoms, as it were, that you can control with electrical flow, much like we control computers with electrical flow through semiconductors. Imagine a semiconductor in just the same way that we do with computers, where you change memory on, off, and gates and stuff of that nature, but with actual matter. So that chair right there, if I applied some degree of electricity to it, I can turn it into a car. Or that projector, I can turn it blue by just changing the electrical compounds inherent in it. That world is a drastically different world, and that world is sitting right at the threshold of today. And if we don't democratize access to that, I fear that world. If we can take that world, oh, it stopped. Let me see if I can get it going for you again. Yeah, there we go. If we don't allow everybody equally to access that, then I'm not sure I want to be around. There is power in this. There is a huge amount of power to allow anyone to create anything and mutate it based off of charges. That in a small subset of hands is dangerous. That in everybody's hands is tremendous. And so I leave you with this note, that the future is right now. It is time to start doing what we all thought was science fiction before you entered into this room today. And most importantly, it's today that you need to go back and teach pre-K through post-secondary school kids these things. It doesn't take you more than an hour, really, to go and say, hey, look, I just bought a cool drone for 50 bucks. Yay! Let's go play with it. And everyone in the neighborhood, everyone at a school will be giddy as can be. The principal will be blown away. Do call them before you show up with one of these, though. Schools are a little bit touchy about that, for good reason. So, but please go back out into your own communities. Take the knowledge that we have here, the incredible smarts we have gathered in this room, give it back out to the world. Give it back out to the next generation, because they're going to replace us very quickly. And I want them to be better than we have been. Thank you very much. I have about 10 minutes if anybody wants to ask questions or anything. Yes? How do people get in touch with their local makerspaces and maker movements in their area? The question is how do people get in touch with the local makerspaces and the maker movement inside their domain, region, city, that sort of breakdown. If you just Google search your city and makerspace, you'll pop up something. The other key term to look for in Google is a maker fair in your city. Most cities at this point have at least one, if not 3 maker fairs going on, and it's run by local people, just trying to bring people together to show off what's going on. That's an option. The beauty of so let me separate those out for you. I'm going to grab the Pepsi real quick. The maker shop or maker space is an area where people gather to make things. A maker fair is where people gather to show off the things that they have made. There's another group out there called NodeBots user groups, and they meet up haphazardly and not well everywhere. That's another access point to gain access to. So that would be sort of what I would go. Yep.
So fundamentally, does the NodeBots boil down to a serial protocol from the controller, PC, or computer?
The question is does a NodeBot fundamentally boil down to a host driving through a serial port to a microcontroller and drive that? That is the original creation of NodeBots, pretty much square on the head. The evolution of it since then has been to use Wi-Fi or BTLE or NFC communications to cut that wire and have the intelligence and the compute over on the host go over some transport medium, whether it be serial port or Wi-Fi, to a microcontroller and drive it from there.
So the reason I asked is that you could implement that serial protocol on the host in a variety of different technologies.
Yep, absolutely. And I use JavaScript. The team out of Hybrid Theory or Hybrid Group, they have built GoBot, which is similar to the NodeBots ideology, but in Go, and R2, which is the similar ideology in Ruby, as well as also Cylon, which is the similar idea in JavaScript. And their idea is to create robot ops, which sits atop all the different languages. And whatever language you want, you can plug it in to this overarching operations control board and be able to control a Go-based one versus a Ruby-based one versus a JavaScript-based one. So that area is very much blossoming still. I only like JavaScript because it's accessible. It doesn't necessarily mean it's necessarily the complete right and only tool for this task. So. Any other questions? Thank you. Oh, yep.
So what are some of the challenges in teaching this to kids? Like what things have come up in your experience?
Okay, so that's a wonderful question. The question is what, based off of my experience, what are some of the challenges that come up when teaching this to kids? If I may, and it's mainly my fault, but it's a piece of experience advice I'm going to give to everyone, would be walking in there with the assumption that the kids aren't already hip to it. Most times when you walk into a classroom, at least for me, and I'm only using my anecdotal evidence, I make the assumption that, okay, I've got to teach you the entire world up. And I'll say, so we're going to use a 3D printer. And they will start going down a path of, well, what about the ramifications of copyright infringement on 3D printing? And I'm like, wait, what? It's because these terms aren't necessarily foreign to them. They are actually seeing this everywhere and fully understanding it. It's not as guarded as it may seem from our position. So I have learned over the time to not go into there assuming that I have to build from the ground up, that I have to first find out where they sit and then train based off of that or work based off of that. So, hey, have you heard of a 3D printer? Oh, you have? Great. What are your questions? Let's get those off the table first, because younger people have awesome ideas and they want to get all of them out. And the best thing to do is to first address that, clear the slate, and then move forward. The other challenges are, up until recently, costing is a problem. While developers are, by and large, paid rather handsomely, not all people in all areas and all walks are. And part of that is trying to figure out solutions, whether it be through Kickstarter programs or, as we've learned doing this, corporate backing. Take money from the rich and democratize it out to everybody. Bring the prices down to the children, to the schools, and make it accessible to them. So that way, I don't have a budget isn't actually a valid excuse for not having this and these programs available. The other one is humans. Like, it's hard to replicate yourself and be at all schools in a county. So that's kind of why I do two sides of the mission, go out and do it, as well as go out and try to encourage and incite more people to go out and do it. Other than that, not too much else. They get it. Like, there's no barrier to entry for them. They don't have a fear. They don't have an angst against it. They just dive in head first. I hope that answers your question. Okay, good. Yep.
So Arduino actually gives you a lot of control over the hardware. So I kind of see both novice users using it, but also people who really use it and kind of diving deeper and deeper. And when you talk about these sort of higher levels of abstraction, it does become more accessible. But I'm wondering how you deal with sort of differences between different hardware platforms.
Okay, so the question is, and please correct me if I misstate it, Arduino gives you a tremendous amount of power that's very specific to Arduino. As you move through an abstraction layer, you lose some of that specific power and capability. Would that be?
More just the control and more things that are hardware specific, so like different sort of Atmel chips.
Yep.
That's going to give you different capabilities. And so when you showed that slide, you know, Spark, and if you're looking at different wireless platforms, they're all going to have different capabilities.
Yep. So it's how do you handle the different capabilities that are native to the platform? Like in this one, it's an Arduino base, so the Atmel chip is going to have a special set of instructions that it can do that are different and disjoint from the Spark one necessarily. So the way we do that is we create the abstraction layer to both afford a base level, so handle your GPIOs in a normal sort of format. And then as part of that, the adapter can present or expose other interfaces that allow access to it. So we don't necessarily constrain them into and pigeonhole them into a singular point. We just say for these generally used pieces, try to conform to this normal set of instructions. And some do, some don't. It's a little bit of a thing, but it's less, in my mind, it's less about making everything conform to an abstraction layer. It's more providing that up into a layer that's accessible. So the concept of do this and when done, execute callback is the key to that element. And as long as that workflow, and it could be promises if you're in the Node world, however you want to execute of go do something, let me know when done, and I will do something else. As long as it adheres to that sort of methodology or that sort of ethos, it's considered, in my mind, a NodeBot. And you very adeptly called out Spark on that one, but there's also, like, hold on, let me get to it. No, there we go. Pinocchio, which has the benefit of being a mesh-based network topology. And I would be remiss to not say that's the coolest thing in the world, because you can do some amazing swarm bots. If we had a Spark here, I do in the room. I didn't bring it because I saw that the Wi-Fi might be shaky, and that's a problem. Like, Wi-Fi isn't necessarily stable everywhere. It's one of the benefits of a cord. It's stable. But it's also one of the benefits of a Pinocchio, which goes on its own band. And the abstraction layers can handle that for you, but it doesn't keep the programmer, the person doing it, away from those pieces. It actually exposes those specialness and allows access to it to control it in that same sort of a higher level workflow construct. Yep. Go here and then over there.
So when you're teaching the kids, is sometimes using a command line and laptop interface a barrier? Would it be easier if you had other interfaces for them to start with?
So that is a great question, repeated. When teaching kids, is the command line a barrier? And absolutely, 110%. This is actually why Chrome now has Chrome Serial. So we can actually use any Chromebook to program any robot. The same libraries that we built for Johnny 5 now run inside Chrome in the JavaScript browser interpreter that's in the browser. If not that, then there's things like Blocky, which allow you to create conditional logic sets with blocks of code and run it through there. We're building that piece up further and further. For this audience, command line is sort of a great thing, and scripts are sort of a great thing, which is great. And eventually, as they start doing either REPLs in the browser or REPLs in a command line, start saving those and running them. And now you start running programs, and you start building up a mentality, or a mental model of how programming in the large works. Good? Question is there a reason why Arduino is a better starting point for getting into these things than a Raspberry Pi or a similar sort of chipset? In my opinion, the biggest one is that the Arduino does one thing and does it well. It doesn't necessarily mean that the Raspberry Pi or the Spark or the Pinocchio or the BeagleBone, any of those aren't capable and aren't already pulled in to this. You could start writing, if you have a Raspberry Pi but not an Arduino, you can write Johnny 5 and it'll control the Raspberry Pi without a problem. And then if you go buy an Arduino, you just swap out and you're good to go, and all the code still runs and the hardware still executes exactly the same, which is really cool. That's the power of it. There's a price point difference. Arduinos are much cheaper. Since the design is open source, you can get it at like $8 for a full board, for better, for worse. Whereas a Raspberry Pi is still not always readily available. They still have shortages based off of stock. Most of that's been cleared up. The other thing is that the onboarding process for Raspberry Pi includes getting an SD card, loading Raspbian, putting the SD card in, getting it to boot up, now set it up to a monitor. And there's so much workflow and infrastructure just to get the 0 point, the hello world, the blinky light. Whereas in Arduino, it's just, okay, put this in and woo, done. Your time to awesome, as I like to call it, is about a minute with Arduino. Full all in is about a minute max. The time to awesome in a Raspberry Pi is about 20 minutes. That's can be a gating factor for people getting on board. It is a lot more propensity for frustration in that 20-minute window than there is on the 1-minute window. Yes?
Practical applications of Pi gauge, things like built-in Wi-Fi and stuff like that, wouldn't that be an advantage once you get beyond the starter phase?
So the question is that's great, Chris, but after step 0, what about the rest of the world? You want to build stuff with Wi-Fi and stuff of that nature. I would address that or respond to that with, you're absolutely right. I would not necessarily go down the path of Raspberry Pi for that. Raspberry Pi is going to be much better if you want to keep the host localized to the hardware controls. Something like Spark or Pinocchio or even BeagleBone Black is going to be better for the Wi-Fi. And each of these, as mentioned earlier, have fantastic special things they do well. The new Edison out of Intel, haven't had access to it yet, but Rick has, and he said it's fantastic. There's a great bridge point there with the Wi-Fi. They each have their own special story. This is the thing about the Internet of Things, is it's still very new, and each one of the players here and beyond focus on one thing and doing it tremendously well. And because of that, they also have one thing that they don't do really, really well. If you want to do something with battery life, you're not going to use a Spark. They have not cared about their power consumption use yet. They will over time, but as of right now, so if you're going to put something like a garage door opener that you're going to control via Wi-Fi, Spark, assuming you don't have a main power line coming in, Spark on a 9-volt battery is going to run down pretty quickly, whereas IMP is tuned for power consumption and can be very delicately controlled to just sip little bits of power as needed. The Pinocchio is great if you're in an area that doesn't have Wi-Fi or has shaky Wi-Fi, like a conference setting. They each have their own little perfect things. Someday, one will have all of them, but for right now, each one has their own. So what I would say is, absolutely right. We generally use Arduinos as just the gateway, the start point. Here's what you can do. Now we have access to this board. Don't change your code. Plunk it in. Look, no more wires. Hooray. Move on to the next task. And then that way, the beauty of it is that same knowledge, the same workflow, the same programming works on all of them. So.
Is it building something like hexing or some sort of soldering? Because you just say you can do this with kids and everything. So I was just wondering,
yeah, this will have to be the last question. I think I'm already over. But the question is kids and soldering irons. A funny story, quick anecdotal funny story. We do an event called RobotsConf where we bring 200 some odd engineer developers of all different languages together. And we were pitching it to the hotel, and we're like, so we're going to set up 9 to 10 soldering stations, and the needles get up to like 450, 600 degrees. Are you cool with that? They're like, wait, what? This was before we told them that we were going to have laser cutters in the room. And so that's a concern, not just for kids, but also adults. Hexi here is entirely screw-based and plugins. So you get, we can talk about this later. Let me get off the stage so that way the next one can get up. Thank you all very much. Please go build robots.